Yeah, welcome to today's class, and I see everybody sitting quiet and smiling. I think yesterday's was a bit challenging. Today is going to be more challenging and more self-explanatory.
Ongoing
Thank
social
you.
engineering
And
techniques.
we are talking about digital data representation and how they are being represented and how they are being recognized in the digital systems. You know, digital data is represented using binary numbers, which consist of only two digits, 0 and 1. This binary system is used to represent information such as text, images, audio, and video in a digital format. Digital data is being represented in binary representation of bits, bytes, shorts, ints, and long. Let's explain one after the other, because most data scientists and experts in the field must have forgotten about all these introductory aspects of data, and they do mistaking them in terms of interview or you're being taken any external examinations. So let's look at what is its bits, B-I-T. The basic unit of digital data is called bits, which refers to binary digits. A bit can have a value of either 0 or 1. 2 is what is called bytes, B-Y-T-E. This refers to a group of bits. So 8 bits is 1 byte. A byte is the smallest unit of memory that can store an integer value. It uses 8 bits to represent a signed integer, which means it can store both positive and negative values. They are used to represent characters, numerals, numbers, and other types of data. A byte has a range of -128 to 127 integers with a storage size of 1 byte, which is 8 bits. This is what major data scientists use to fail in an examination. So let's go to shorts. Short refers to 2 bytes data, which consists of a 16-bit integer. A short is a 16-bit integer that can store signed values. It has a large range than a byte and is often used for variables that require a smaller range than an integer. It has a range of -32768 to 32,767 and has a storage size of 2 bytes, which is 16 bits. So we have int, that is int. An int is a 32-bit integer that can store signed values. It has a large range and is often used for variables that require a wide range of values. Bit length is only 32 bits. It has a range of over 1 million plus with a storage size of only 4 bytes. That is 32 bits. And we have long. A long is a 64-bit integer that can store signed values. It has an extremely large range and is often used for variables that require a very wide range of values, such as timestamps or large numerical values. Long has a bit length of 64 bits with a range of -19 digit and +19 digit, which is up to 1 trillion integers each, and it has a storage size of 8 bits. So which means any computer that have up to these 64 bits can process 1 trillion bits of information in second. So each of these integer data types has a specific bit length, range, and storage size. The choice of which data types to use depends on the specific requirements of this variable or application, and also types of storage or memory system. If you have any question, you just type it. Let me see. As you are typing it, I'm taking it up. So, and any question from any left, right angle, I'm listening, I'm going through, and I see, okay, someone is typing, okay. Okay, you say, why do we have a 32 bits and a 64 bits system? I think you are referring to a computer, laptops or computer. You know, most of the personal computer system is rated 64 bits and 32 bits. The term 64 bits and 32 bits refers to the laptops or desktop processor architecture and operating system it runs. Let's check processor's architecture. We all know what bit is, and from our previous explanation, which makes us to go to word size. Word size is the number of bits that a processor can process simultaneously. A 64-bit processor has a word size of 64 bits in a second, while a 32-bit processor has a word size of 32 bits in a second. So a 32-bit processor can process 32 bits of data at a time. It's limited to addressing only 4 gigabytes of RAM. You can't expand a RAM up to 6 gig 32-bit processor, while a 64-bit processor can process 64 bits of data at a time, and it can address much more than 8 to 16 gigabytes of RAM. You see, you can expand it, so making it more suitable for demanding applications. And you see that while laptops and desktops are labeled as 64 bits because they have a 64-bit processor and run a 64-bit operating system, this means they process more data simultaneously, address more than 16 gigabytes of RAM size, making them more suitable for demanding applications. That is all about the 64-bit processor and 64-bit operating systems. And a 64-bit processor runs 64-bit applications and operating systems and are far more better and faster than a 32-bit rated laptops and desktops. Time is over. I think let me give you an assignment. Design a structure of an application that is programming or program that can count the population of ants in an ant kingdom. Submit it before the class using any of the channels provided. See you next class.